Now, when it comes to current, there are two main types that you need to know about: alternating current, commonly written as AC, and direct current, or DC. In an alternating current, the direction of the current is constantly switching back and forth. That means the electric charge flows in one direction for a moment, then reverses and flows the other way, and continues repeating this cycle. Alternating current is generated whenever we apply an alternating potential difference, essentially a voltage that oscillates between positive and negative values over time. If we were to measure this voltage or the current using an instrument, and then plot it on a graph over time, we'd see it rising and falling in a wave-like pattern, constantly fluctuating above and below zero. At the circuit level, this fluctuation means that the direction in which the electric charge moves also keeps changing back and forth. Here in the UK, all mains electricity, the kind that comes from plug sockets and powers household appliances like computers, toasters, or kettles, is alternating current. More specifically, the UK mains supply operates at a frequency of 50 Hz and a voltage of around 240 volts. This means the voltage waveform alternates from positive 240 volts to negative 240 volts and back again, 50 times every second. So, the current in the wires follows that exact pattern, switching directions 50 times per second. It's worth noting that you might sometimes hear people say the mains voltage is 230 volts rather than 240, and that's okay. Both values are accepted for exams, and the actual voltage can vary slightly in practice. Now, direct current works differently. It's produced by a direct potential difference that remains either entirely positive or entirely negative. As a result, the electric charge flows in just one direction, constantly, without reversing. This is the type of current you get from things like batteries and cells, whether it's the AA battery in a remote or the rechargeable battery in your smartphone or calculator. Lastly, when we want to capture these voltage or current waveforms and actually see how they vary over time, we use a device called an oscilloscope. An oscilloscope visually displays how voltage changes in real time, typically as a graph on a screen, allowing us to observe the patterns of alternating and direct currents. And that wraps things up for today's video. If you found this explanation helpful, don't forget to share it with your friends, drop a like, and subscribe to the channel, and we'll see you next time.